Hello, everyone. My name is Wafa Johal, and I'm a senior lecturer at the University of Melbourne. Very happy to talk with you and to participate today. Today I will talk about robot-assisted decision making and how, with the anthropomorphization of AI through large language model being used in chatbots like ChatGPT, or even through the use of these models in social robots, how we could put at risk um, users in thinking that these agents, social agents, actually convey utility instead of likelihood. So let me start with a story, and a story that I borrowed from a former colleague, Tim Miller, at the University of Queensland, and I adapted it slightly to social robots. So imagine that um, at your office, you have two social robots that can provide assistance and be consulted for decision making. Imagine that these two robots have been useful for your colleagues in the past, and so they're quite good. So the first one, Bluster, goes straight to the point. So whenever you go ask for advice to Bluster, it gives you recommendations right away. And the recommendation of Bluster might be maximizing the likelihood of an outcome, or also maybe maximizing your happiness because Bluster is a cool guy. The other social robots that you have available is called Prudence. And Prudence will not give you a recommendation, unlike a Bluster. Prudence instead will question your choices and will actually enter into a discussion with you to question and understand why, what is behind every decision. So, and it can be frustrating, can take a bit longer. So now let me ask you to think a little bit. If you had an issue in your office, which of these two social robots would you go and consult? You might tell me, well, it depends. Like if it's a very simple matter and I need a straightforward recommendation, maybe Bluster would be fine. But in most cases where you actually need to take a difficult decision, a lot of people actually tend to choose prudence. And why would we choose prudence? Well, prudence kind of helps us to identify and think about the decision, and also gives us control over the decision itself. So despite the fact that most people would probably prefer prudence, most of the AI assisted decision making systems at the moment actually are using the Bluster model. And this Bluster model is what Tim called recommend and defend. So basically, the system is going to give you a recommendation, and then it will defend or justify that recommendation. So now the problem with this kind of approach is in twofold. So the first one is with this Bluster model. The first one is that these recommendations, they're actually made under uncertainty. And if the system makes some mistakes, you might tend to undertrust it. Or if it doesn't make any mistake, you might overtrust it and not perceive this uncertainty. So we kind of risk this like trust imbalance issue because of the uncertainty being hidden with behind these recommendations. The second issue is the fact that this kind of approach where you're given a recommendation straight away kind of reduces your feeling of control, and also can cause fixation because it might not allow you to reflect on all the possible options that you had and just drive you to like one unique solution. So if we go back to actually the basics of decision theory, and this is something that I've actually just borrowed from a textbook I use, Artificial Intelligence, a Modern Approach by Russell and Norvig, where there is a chapter about decision theory and how decision theory can be decomposed in two sub theories: utility theory and probability theory. So probability theory is going to tell us about what is the likelihood of a certain event to occur, like for a certain event to occur. Okay, what is the probability of um, this outcome given that I take this action? Okay, so that will be probability theory. on the other hand, utility theory is going to tell us how preferable is this outcome. Is it an outcome that I'm trying to maximize, or is it something that I don't necessarily want to? And this preference, this utility theory, can actually be very hard to craft and to model, especially when we're talking about decisions on social issues. A utility theory, when you're talking about a social robot or a personal robot, might be very difficult to craft, and happy you might have to balance actually like ethical issues. So it might be very hard to model. So my argument here is actually that we should not at all deal with utility theory, I think, for social robots, and we should just stick to probability theory. And that our social agents that are interacting with users should make it clear that they can do recommendations on likelihood of events with uncertainty, but that the decision should stay for the human to do, and the utility theory needs human input. So this is actually something that we've started to explore with my team and with my PhD student, Sarah Shams. And I'm going to now present a few results that we presented a few weeks ago at CHI on this paper, Robot-Assisted Decision-Making, Unveiling the Role of Uncertainty, Visualization, and Embodiment. And this is some work that we did with some colleagues at the University of Melbourne, Soumya Parekh and George Concalves. So in this study, we're actually considering robots as a whole. So robots are deployed in complex environments. There might be like some flaw detection in the model, faulty sensors, navigation failure, sensor failure, etc., etc. But how to communicate the fact that this uncertainty that robots are dealing with to a human collaborator. So in our study, we investigated the uncertainty visualization through two different modalities. A graphical user interface, that is a classic in information visualization, and the other one is an embodied visualization that we designed based on human-robot interaction research on hesitation. The other thing we explored was kind of to display different level of confidence and uncertainty. So the robot might be low confident, high confident, or 100% confident. That means that there was no uncertainty on its sensor. So the context, as I said, was a human-robot collaboration task. It was a packing task where a user would pack pillboxes with a human. The robot would pack pillboxes with a human. And then it was a high-stake scenario because we were talking about pharmaceutical environment where the user will actually pack pills, and some of the pills might be defective. So I'm going to move on to show you directly the video. So here we see the robot picking up one of the pillbox from its stash down to the end of the video there, and the participants taking one from its stash and then packing it together. So we were instructing the participant, telling them that their pillboxes have been tested and they're all fine. So the ones are on the low table, but the one on the high table there are actually might be defective and might not be ready to be shipped. So the robot will actually display the uncertainty, the level of certainty on how defective the pillbox is. So if the robot was very confident that the pillbox will be good, it will display 100%. Okay. If not, it will be uncertain and display less than that. Okay. So we had, as I said, two modalities. We were comparing graphical user interface and the actually embodiment using motion. So this is what it looked like from closer. So we had hooked an iPhone on the grip of our robot to display this icon array. That's a classic. We've actually did the manipulation check to make sure that it was understandable, that this was a certain percentage of confidence. And the robot will actually just display this as it was moving the pillbox. In the embodiment, we used some literature in displaying hesitation through motion, and we designed two types of like gesture for the robot to convey hesitation. The first one was waiting time, so the robot might wait, showing that it's uncertain, hover over the pillbox. and the other one was travel time. So the robot, as it's less confident, will take more time to put the pillbox in the package. We then asked participants, after packing these pillboxes, should it be sent to shipment or need additional testing? And this is our decision-making behavior. So given the visualization about and the information that the robot might have shown them with the visualization, now are you able to determine if it's fine to send it or not and need additional testing? And we also ask a few questions about trust and general understanding. So the results were super interesting. So, to our surprise, even when the robot was showing 100% confidence, only in the embodied group, we saw a high level of people taking the correct decision and shipping the packages. So that means that the graphical interface wasn't as efficient in getting users to the right decision. But why that? It was actually because people would doubt about the graphical interface, but not doubt about the embodiment. And that's something that we found very interesting. And that's also something that could be risky when designing this embodied social agent, is that the uncertainty due to the agency of the robot might not be perceived as strongly. Okay, so we found a bunch of other takeaways with this study, and the fact that we need to be very cautious when we're visualizing a fully confident robot, especially using graphical interface. Visualizing uncertainty is highly context dependent, so users and participants need to understand actually what is at risk here and what could be the damage of sending a pillbox that is defective. And finally, conveying uncertainty does not necessarily affect trust in the robot. And that was something very interesting, that the trust was not really linked with the level of uncertainty. So, to go back to my point, I think when we're talking about social robot assisted decision making and anthropomorphizing a bit more the AI behind the social robot, we actually need to take care a lot about the communication and the agency that we're giving our robots. So by actually having a robot able to communicate with natural language, we're increasing agency, and hence we might lead our users to think that this agent knows about the utility of the decision and does not only communicate about likelihood. So I want to show you now another project that we did, actually trying to leverage this agency. And this is also a visualization work that done by Sarah, where we're using the face of a robot here to display harassment data. And the idea here is to actually provoke the thinking. And by using this agency, you can also provoke more thinking when visual than just showing a bar chart. So with this, I'd like to conclude and to thank you all for listening. Happy to answer questions. I'm present on social media, on Twitter, LinkedIn. So if you have a question, just DM me, or you can also send me an email. Thank you for your attention, everyone. Bye.